horizon line and camera angle play a key role when it comes to perspective. Understanding these two will help you determine the horizon line position of a photo. Choose or shoot the right angle for your photos, and place objects in the correct position. So what is a horizon line? A horizon line is where the sky meets with a surface like land or water. In real life, this line sits at the height of the viewer's eye. In the case of photos, it sits at the height of the camera when pointing at an object. In this diagram, we can see the distance between the ground and the photographer's camera. That's where the horizon line is. It does not matter whether the photographer is standing, leaning down, or lying on the floor. The horizon line position is always in line with the camera's height. It's essential to keep in mind that every photo has a horizon line. And since in compositing, we use different objects from different photos, it's absolutely crucial to identify the horizon line of each photo. Knowing where the horizon line for each object is, will help you match them together and place them in the correct perspective to create a realistic composite. Let's look at some real-life examples. In this first photo, we can clearly see where the horizon line is. The line is between the sky and land. And in this second photo, the horizon line is evidently between the sky and water. And for the third photo, it's between the sky and the ground. In this case, the mountains are not taken into consideration. An important thing to keep in mind when working on an artwork is that you can only have one horizon line in any composite. In the same way that a real-life photo has only one horizon line, so should your composites if you want them to look convincing and realistic. Let's say your composite will be made up of 5 different source photos. Each of these 5 photos has its own horizon line, and when compositing these photos together, you need to make sure to match all 5 horizon lines into one. So let me recap. Like in real life, you can only have one horizon line in your artwork, and all objects in your composite need to match it. Failing to do so will result in elements looking out of place, ruining your whole photo manipulation. Sometimes it is easy to spot the horizon line in a photo, especially when you have the sky meeting the land or sea like the examples we've seen earlier. However, what if there is no sky and land in the image? And what if we cannot see the horizon line because it's outside of the picture? Or what if you are using source photos that are isolated on a white background? That makes it a bit trickier, but we still need to know where the horizon line is so that we're able to match all horizon lines in our composite. So what do? That's where the camera angle comes into play. We've learned that the horizon line is in line with the height of the camera from the ground. But when looking at a photo, we see the picture that a photographer shot, but we don't see the photographer, so we cannot tell the actual height of the camera. But there is a solution for that. In such cases, we can approximately determine the horizon line using the camera angle of the image. There are 3 main camera angles we use when doing this exercise. Let's start with the first one, which is the straight-on camera angle or the camera pointing straight. When a camera is pointing straight, the horizon line is in the middle of the photo. So looking at this photo, we can see that it was shot straight on, so the horizon line should be somewhere in the middle. The second one is the low camera angle or the camera pointing up. If the camera is pointing up, the horizon line is somewhere in the bottom part of the photo. Looking at this photo, we can tell that the camera was pointing up, so the horizon line should be somewhere in this bottom region. And the last one is the high camera angle or the camera pointing down. When the camera is pointing down, the horizon line will fall in the top part of the photo. So in this photo, the horizon line should be somewhere in this area. So with the camera angle exercise, we can get an approximation of where the horizon line is sitting. But most of the time we can refine that even more. And we do that by studying the photo. So what are we looking for? Okay, so there is something fundamental that we need to remember. And that is: 1. We cannot see the top part of something if it is above the horizon line. And 2. We cannot see the bottom of something if it is below the horizon line. I call this the above or below horizon principle. Looking at this diagram, we can see that this cuboid is sitting above the horizon line, and as such, we cannot see its top part. So if we cannot see the top part, the horizon line is below it. Got it? And if we look at this other cuboid, which is sitting below the horizon line, we can see that the bottom part is not visible. So since the bottom part is not visible, we know that the horizon line is above it. And the less we can see of the top or bottom, like these cuboids here in the middle, the closer the horizon line is. For example, we can see more of the top of the bottom cuboid compared to the one closer to the horizon line. This is easy enough with cuboids as they have a flat top, but with spherical or rounded objects, such as a human head, this becomes a bit trickier. Let's take a look at this sphere as our first example. We are looking at the sphere straight on, yet one might say we can see the top part since we can see this area here. But when using the above and below horizon principle, when we say we can see the top part, we are referring to this area here. Therefore, being able to see the top part of a sphere means we have a top view of the uppermost area. And of course, the same goes for the bottom of the sphere. With that in mind, let's go back to the straight-on view and find the horizon line of the sphere. Here, we cannot see the top part, but equally, we cannot see the bottom part, which means the horizon line is precisely in the middle. However, if we rotate it a bit, we can see a bit of the uppermost part. So the horizon line should be a bit further up from that area, somewhere here. And if we rotate it a bit more, we can see more of the uppermost part. For this angle, the horizon line would be even further up. Somewhere here. The same concept applies to a human head or any somewhat rounded object. Here is an example. This is a straight-on view of a human's head where the horizon line sits in the center of the face. But if we rotate the head a bit, we can see the top part, or uppermost part of the head, and therefore the horizon line would sit somewhere here. Let's look at a final example, this time, a whole body of a tiger. We can see the top part of its paws, but we don't have a top view of its head and cannot see the uppermost part. This means that the horizon line is somewhere between the head and the paws. Looking more in detail, we can see the bottom of its neck but not too much. Therefore the horizon line is somewhere here. But what if I rotate it a bit? In this case, we can see the top of its paws but even the uppermost part of the head and back. Therefore, the horizon line is further up from those areas. I would say that the horizon line is somewhere here. So it's important to understand that when looking for the horizon line of objects such as humans or animals, you need to be able to see the uppermost part of any rounded shape. This is usually the head, shoulders, or back. But if you cannot see the top part of those areas, move on to the other body parts, such as hands, feet, etc., until you can determine the horizon line position. And that's it. So using this trick, combined with the camera angle theory, should help you determine the position of the horizon line quite precisely. And even if perhaps the camera angle is not so predictable, you can still use this trick on its own. So now, let's put what we've learned into action. We'll look at some photos which are not so straightforward and use the camera angle method to approximate the horizon line. Then, we'll refine further by examining the image and fine-tune the horizon line position. Looking at this photo, we can see that the camera is pointing down, therefore, the horizon line is in the top part of the photo. Now, to find the exact position, we can look at the details. We can see the top of the man's feet, and we can even see the top of his shoulders, so the horizon line is further above. Remember, the less we can see the top or bottom of something, the closer the horizon line is. And since we can see a bit of the uppermost part of his head, but not much, the horizon line should be somewhere here. Cool, right? Now let's move to another photo. In some cases, we might have extremely high or extremely low camera angles, putting the horizon line outside of the photo, like in this second photo. But we can still examine the photo and determine the horizon line. For instance, we can see the bottom of her breasts, so we know the horizon line is further below. Now, we cannot see under her face, but that's because she is looking down, so we'll ignore that. It's safe to say that the photographer is kneeling on the floor with his camera pointing up. And since the horizon line is always in line with the camera's height, we can guess the horizon line is somewhere here, below the visible part of the photo. Again, since we can see some, but not much of the bottom of her elbow, the horizon line must be very close, and I'm guessing it's somewhere here. Let's look at one last photo. Without any doubt, the camera is pointing down, therefore, the horizon line is sitting somewhere above the subject. The camera is pointing extremely low since we can see a lot of the deer's back. We can even see the top part of the deer's head, meaning the uppermost part. With these considerations, we can assume that the horizon line is outside the photo, somewhere here. Bear in mind that with such images, it's not always possible to be 100% precise. So what we're trying to do, is to make an educated assumption based on the information we have on the photo and approximate the area where the horizon line is sitting. The more you practice, And the more you study different photos, the better you'll get at it, and the more convincing and realistic your composites will look. Now that we know what a horizon line is and how to find its position using the camera angle and the details in the photo, we can move on to the next lesson of this section. But before that, let's do a recap. A horizon line is where the sky meets with land or water or the actual height of the viewer's eyes or camera. You can only have one horizon line in a composite, otherwise, your artwork won't look realistic. Each source photo used in a composite has a horizon line. We need to align the horizon line of all these photos together and merge them into one. With not so straightforward photos, we can find the horizon line by determining the camera angle and studying the details in the picture. Keep in mind the above or below horizon principle that we cannot see the top part of something if it's above the horizon line, and we cannot see the bottom of something if it's below the horizon line. The less we can see of the top or bottom of an object, the closer that area is to the horizon line.